Hi guys, in this video I'm going to be teaching you guys how to create computation graphs in TensorFlow. So in this video I will be covering the basics of a computation graph, and we will define nodes, edges, dependencies, and we will also provide some examples to illustrate the key concepts. So let's begin. Alright, so let us first define the computation graphs. So every TensorFlow program has a computation graph which determines its computational structure. So a computation graph is basically a series of functions chained together. So the output of one function will be input of the other function. So look at this picture. So this picture shows basically addition. So it takes two inputs and sum them up and gives you an output. So in this graph we have nodes and we have arcs. So basically arcs show the values or information, and nodes show the operations or computations. So this is a fairly simple example of a computation graph. Here is another example which is a bit more complex. This example takes two inputs which might be coming from a different graph. I've labeled each node from A to E. When it comes to implementation in TensorFlow, so each node will correspond to one object. Nodes A and B are input nodes. They simply pass on the values given to them. Node C is an addition node, and nodes D and E are multiplication nodes. We also need to talk about dependency. So we say that E is directly dependent on nodes C and D. By this we mean that the data must come directly from both nodes C and D in order for node E to be executable, to be computable. We also say that E is indirectly dependent on nodes A and B, which means that the outputs of A and B do not feed directly into node E, but node E indirectly depends on nodes A and B. Circular dependency is not allowed in TensorFlow. For example, in the current graph, node B cannot depend on node E because that would cause a circle. TensorFlow has a two-step workflow: define the computation graph and run the graph with data. In this video we will only be focusing on defining the computation graph. So let's try and implement this computation graph in TensorFlow. So let's go to the VirtualBox. Let's start our Ubuntu OS that we created in the previous video. Let's save it in the desktop. My documents. Comp graph. .py and import TensorFlow CF. Now A is equal to TF dot constant of let's see. is constant and is equal to 4, and name is equal to input underscore a. Alright, so what this line is doing, so the first line is just importing the TensorFlow library with the name TF, so that we can be able to use it later on. So this second line is creating a TensorFlow object, a constant object, and it's basically this node. We're creating this node, and it's constant. This second argument, it's optional, but when it comes to drawing the actual graph using TensorBoard, these labels, this label would be much more useful because it would actually show the label in the graph. So let's do the same thing for the other input. I'm just going to copy and paste this over here, and let's call it B. Alright, so the other one was 3. And input B. Alright, so let's create node C. C is equal to TF dot. Alright, so node C is an addition. TF dot add, and addition of node A and B, and name is add underscore C. How about D? D was multiplication of A and B. Alright, so this is going to be D. This is going to be mul for multiplication, and mul underscore D. So this third line is creating an addition node which takes nodes A and B, and its name is add underscore C. The name part is optional, but again, if you give it a name, it will show in the graph. Alright, so let's create the last node, which is, I guess, a multiplication node. Let's copy this part, and E, multiplication of C and D, I suppose. And name should be mul E. Alright, so this is how you create this computation graph inside TensorFlow. Alright, so how to output the graph in TensorBoard. So now you've created this graph, but you have no way of showing it as it is. So you can draw it in TensorBoard. So let's do that. Alright, so the first step is to actually go to Python shell and type all of these lines plus the following lines. So alright, so let's do this. Before that, we can try some of these codes. So let's just try. SESS is equal to TF dot session, and it's with a cap S. can actually, let's print this part, css.run of e. So what this run function is saying is that it's saying to SESS to actually compute the value of node E. So it should give me 84. Alright, so let's try and run this in the terminal. So this is important for me to know where it is saved, because I'm going to need its location. So this is where it's saved. With Python, I need to paste that part. What was the name? Comp graph. Alright, 84. Looks nice. Alright, so let's get back to here. Now we need to go to Python shell and type all of these lines plus these lines. Alright. So this is Python Alright, so this is the terminal. I just need to type in Python to go to Python shell. And now I need to copy and paste all of these lines. So let me just copy this part and paste. And this part. Let's go back to the slides. Now I need this one, tf.train summary writer, and so writer is equal to tf.train summary writer. Alright, so the first argument is my graph, my underscore graph, and the second argument is, and these are inside single quotations. The second argument is SESS.graph. Let's see. Alright, so now we're done with this. Just call exit. Now we're back in terminal. Now in terminal we need to type TensorBoard log dir equals my graph. TensorBoard log dir equal my underscore graph. Alright, starting TensorBoard 29 and 6006. So what we need to do is to go to Firefox or any browser. And we need to type in this address. What happened? Uh, 127.0.1.1 is basically a local host with and if you do that, it will give you this page. Now in here you should go to graphs. Alright, so if you zoom in, we can see that you can actually get the graph from the TensorBoard. So it appears that it's duplicated this input A, but if you go over one of these, you will see that the other one is also highlighted, so they're kind of linked. It's not duplicate. So that's it for this video. So in this video you've learned what computation graphs are, and you also learned how to create them. Thanks for watching.